Hello! I've just published this very video, but in another format, and then I remembered that I have a whiteboard, so I'll try again. We have a physics problem, a motion problem. We have an astronaut on another planet who throws an object, and we want to understand, to find the distance at which the object lands, okay? Now, we can neglect, for this problem, we can neglect the height of the astronaut. And we say that gravity is gravity with a little thingy. No, you cannot zoom. But do you see? You kind of do. Okay. Okay, going down. We have velocity. Velocity v. Okay. We have an angle theta of 30 degrees. Then yeah, x-axis, y-axis. And what we are looking for is this distance L, where the thingy lands. Here we have thingy, the mass lands. Oh yeah, I forgot to draw the mass. This is a happy mass, just flying. Okay. This is time equals 0, and this, the initial time, and this is the final time, big G. Yes. So, well, I would write everything, but it would be like the same size. Then I can just write it bigger. Okay, so we have a mass, like the givens, gravity, theta, which is 30 degrees, and then a velocity. Okay, we can start with the motion formulas, are they called? I don't know. I studied in Swedish, I didn't really understand the word when I first heard it, and now I don't know it in either language. Anyhow, we start with these formulas. X, when the time is initial, is equal to V0 time, while Y, when time is initial, is equal to H, like the height, which in this case is 0, plus still V0 t, and well, plus minus G, because it's in the negative direction, over 2, G t squared over 2. So, and this is one part. We know that the velocity, the initial velocity, which I will write as V0. Can you see things? Yes, you can. I keep on checking because I see everything very small, but this is a phone, so yeah. And I'm quite far away, so I assume. Okay, V0x would be V0 cos theta, because we're in the x-axis, and V0y would be equal to V0 sin theta, okay, because we're in the y direction. And this is another detail, okay? And then we have, then we can set equals, formulas to equal each other. No, not yet. We can also say that this is when the time is initial. We can set the formulas to the time final. So, I will just sit down. Look at this. Oh, I can also just get closer. Everything. Okay. We can do this. We can do this. I will let you look at this, like watch the struggle as it happens. You know. It's kind of stable enough. Okay. Yes. So now we will set x big T equal to L, because here on the x-axis, when the time is, like when the mass whoop falls down, that's the distance that we're looking for, while y big T is equal to 0, right? Because like now it's on the ground again. We set the formulas equal to each other. The first x equal to this, and the last x equal to that. And the like this, the first y equal to the second y. I'm a bit tired. So, whoop, we have that v0t. No, we can actually write it well. Or we can actually use the cos. v0 cos theta t is equal to L, and that I will not write the h because it's just 0 plus v0 sin theta t minus g t squared over 2 is equal to 0. Now what we will do is we will focus on this formula as the first step, and then we will go on to this formula. Hold on, maybe it's not gonna be needed. We'll see. Just the process. So, next step. We want to set in the t, okay? We will set in, like this t is kind of general. Maybe I could write like t is, no. I could write, no, this t is general. This is t0, this t is general, and we will put in the final t. And the final t, okay, so like this t. The final t can be found using the SVT formula, SVT, which fun fact is also Swedish radio. S is distance, V is velocity, T is time. So to find time is equal to SV, which in our case, the distance is L, and V is V0 cos theta. Okay, because like we're looking for the y, no, we're looking for the x. Yes, so we set this formula in here. So we have v0 sin theta L over v0 cos theta minus g L squared to v0 cos theta squared. Yes, equals to 0 still. Should I? Yeah, I can do one more line here. We can just put this on the other side. So v0 sin theta L or v0 cos theta equals g, the minus disappears, v0 cos theta. I think I got a good night message, have to answer those. We wanted to cancel out things. And now we can cancel out, what pen should I use? I can use the blue one. No, maybe it's not gonna be that visible, it doesn't matter. So we'll cancel out the L's, we'll cancel out, because we're winners, we'll cancel out the cosinuses. And so we end up with some other very happy functions. We end up with v0 sin theta equal to GL, losers, I am that childish, yes, cos theta. Oh, this thing is starting to hurt. And what did I want to say? Oh yeah, and we are looking for the distance. So we're looking for the distance, and so we have to isolate it. Bad idea to tie your wet hair, but it's fine. So yeah, so whoop, we just multiply by this, so we get 2v0 cos theta v0 sin theta. Then we divide by g, so it is equal to gl. Then we divide by g, and we get L. We're not yet done, we're very, very close, but there are still some little, in Italian it's accorgimenti, how do you say it in English? Nuances that we have to take care of. So, what we have is the trigonometric rule that says that 2 sin theta cos theta is equal to sin 2 theta. So, and that's exactly what we have here. So, yeah, you can see. So we can rewrite this to v0 sin 2 theta over g equals L. Not yet done. Remember that we have the angle 30 degrees. Since the angle is 30 degrees, we have that 2 theta is equal to 60 degrees. And we look at the unit circle. Whoop. At 60 degrees, sin theta is equal to square root of 3 over 2, okay? And so we can plug that in. And we get finally the final answer of v0 square root of 3 over 2g. And that is equal to L. Can you see? Yes, you can. Peace.